Right now, you're looking at renderings of futuristic human settlements on Mars, the red planet that has fascinated us for generations. These aren't just science fiction daydreams. They're real designs submitted to NASA's 3D Printed Habitat Challenge, a bold 4-year-long competition that sought to answer one of humanity's most daring questions: how do we build homes on another planet? With the stakes this high, the brightest architects and engineers from around the globe came together to test their ideas, culminating in a nail-biting finale that saw 2 top teams go head-to-head, printing their Martian habitat prototypes live in front of NASA judges. It was the ultimate test of innovation, endurance, and the future of space exploration. Mars, with its mysterious red hue and Earth-like terrain, has long been the center of our cosmic curiosity. Its proximity and potential for harboring life have made it a popular destination for robotic missions. But despite its familiar look, Mars is far from hospitable. The temperature swings drastically between night and day, think desert extremes multiplied exponentially, dropping to a frigid -70 degrees Celsius at night. This is largely because Mars has a very thin atmosphere, less than 1% the density of Earth's, which offers almost no insulation or protection. In fact, Mars is practically a vacuum. Add to this the lack of a magnetic field, and you have a surface constantly bombarded with harmful solar and cosmic radiation. To survive on Mars, we must construct habitats that can shield humans from these deadly conditions. And because importing materials from Earth would be astronomically expensive, these homes need to be built using local Martian resources, with 3D printing emerging as the most viable solution. Enter Aerospace Factory, a cutting-edge architecture firm that developed one of the most innovative designs in the competition, Martia. Unlike traditional rectangular buildings, Martia features a vertical, egg-shaped structure. This isn't just for aesthetic purposes. A cylinder printed vertically is an ideal shape for a 3D printer. It's stable, predictable, and efficient to build. The pressurized interior of the habitat requires a design that can handle the outward push from within, and the egg shape distributes this pressure more evenly, reducing structural stress. Every aspect of Martia was meticulously engineered, from the structural integrity to the interior layout. It included essentials like a rover docking port, skylight, and windows to provide both functionality and psychological comfort for its inhabitants. Material selection was another vital part of the challenge. On Mars, water is a scarce and precious resource. That meant concrete, which relies on water, was not a practical choice. Instead, the team opted for a type of thermoplastic polymer that could be sourced and manufactured on Mars. This material doesn't require water and offers another critical advantage: it can be reheated, remolded, and reused. In other words, it's recyclable, a vital feature when dealing with limited resources and the need for sustainable living. With their vision in place and materials selected, the Aerospace Factory team poured everything into the competition. They scraped through the first phase, rallied to secure second place in the second phase, and then reinvested their prize money to push harder for the final showdown. This last leg of the challenge was a week-long, high-stakes event where the top 2 teams were invited to print a 1/3 scale version of their habitat live, in front of NASA judges. It was the first time they'd be printing the full structure in one go, no more piecemeal testing. They had just 2 days to set up their machinery and 30 hours, spread over 3 days, to print the entire structure. It sounds simple: hit play, and let the printer work its magic. But in reality, every step required active supervision and problem solving. Every time the team needed to intervene, even for a small adjustment, the judges started a stopwatch and counted it as a penalty. From laying the foundation on the first nerve-wracking day to reaching unprecedented heights on the second day, the team had to stay calm under pressure. By the third day, the pressure was intense. Thanks to a shift to single-layer printing, they were able to build the final 7 feet of the structure in just one day, a task that normally took them 2. The last task was placing the skylight, and as the clock ticked down, the tension in the room was electric. Keep going, they urged, releasing the skylight at exactly 6 p.m. For a moment, it seemed to hold, until it came crashing down. Despite the final hiccup, the judges were impressed by the strength, innovation, and build quality of Marcia. After a series of structural integrity tests, the verdict was in. First place went to AI Space Factory. The announcement was a moment of triumph, not just for the team but for the idea that space-age technology could shape our future on other planets, and maybe even improve life here on Earth. The story doesn't end there. The lessons learned from Marcia are now being applied to a new project, Terra. Located in Garrison, New York, Terra is a full-scale, fully functional Earth-based habitat, made using the same materials and methods developed for Mars. It's a bold experiment in sustainable living, and a statement that the solutions we design for space can have real, meaningful applications on Earth. Built just an hour from the team's Manhattan office, Terra serves as both a home and a model for how we might build smarter and greener here at home. What makes this project even more compelling is the philosophical stance behind it. In today's world, there's often a false dichotomy: either we invest in space exploration, or we focus on solving Earth's climate crisis. But as AI Space Factory's work shows, it doesn't have to be one or the other. In fact, the innovations developed for the harsh conditions of space could be exactly what we need to build a more sustainable future on Earth. This is a beautiful fusion of ambition and responsibility, a vision where space travel doesn't distract us from our problems, but inspires the solutions. So what's next? It may still be decades before humans set foot on Mars, but the technology to house them is already here. And if you're fascinated by what it takes to build a second home for humanity on another planet, you're going to want to stick around. Because this story isn't just about one competition, it's the beginning of a new chapter in human history. A story where sustainability, innovation, and exploration go hand in hand. And if you thought Marcia was impressive, wait until you see what happens when these teams aim even higher. Subscribe, stay tuned, and join us as we explore the cutting edge of architecture, science, and the human spirit.